Okay, let's discuss this interesting problem. It is a very common problem based on voltage regulator using Zener diode. Okay, now let's understand the problem. Here is one load. Okay, now this load is dependent on the user, so it is not a constant value. Okay, not a constant resistance, so it depends upon the user. At the same time, there is a source which is also not constant. It is changing between minimum and maximum value. Okay, now the task is to find out the value of RS such that this circuit work as a voltage regulator, means this load is getting a constant voltage across its terminal. Okay, now this is only possible if this Zener diode is in breakdown. Okay, now let's understand. Zener diode will be in breakdown only if it gets minimum current. Okay, if it does not get minimum value of current, then it will not be in breakdown. That means it will not act as a constant voltage device, and this load is not going to get the constant voltage. Okay, so we need to make sure that this Zener diode is getting the minimum current at all condition, even though this is changing, even though this is minimum or maximum, even though the load current across this terminal is minimum or maximum, don't care. The circuit should work in worst possible case, that is, in worst possible case this Zener diode should get minimum value of current, then only it will act as a voltage regulator device. Okay, so we have to perform a worst case analysis, and in worst case this Zener diode should get minimum current. Okay, now in the question it is mentioned the load current is varying between these range. Okay, this is the minimum value, maximum value. Likewise, the source voltage is varying between these two range. This is minimum value and maximum value. Okay, now let's understand what should be the worst possible scenario. Okay, let's understand. This source is minimum, but the load is demanding maximum current. I repeat, the source voltage is minimum and the load is demanding maximum current. Okay, this is one possible scenario of the worst case. Okay, another worst case could be this is minimum and this fellow load is demanding the maximum current, means when the source voltage is minimum, the load is demanding maximum current. Okay, so in these two cases, these two worst cases, we have to write down the equation and find out the value of RS. Okay, taking into account that the current across the Zener diode should be more than its minimum value, then we are going to get the value of RS. Then we can easily solve and find out the value of RS. Let's understand. Okay, let's write down the equation in the first worst possible case. Okay, I am considering this as minimum and this is maximum, and the current through Zener diode should be more than its minimum value. Okay, so let's write down the equation for Zener diode current. Okay, I am writing V minimum minus Vz. Why Vz? Because this should always be in breakdown. Okay, that's why I am writing this current, basically V by RS minus, this is the incoming current, this is the load current. Okay, so this current, basically I am writing the equation, minus IL maximum. Okay, IL maximum should be more than IZ minimum. Okay, so this is one equation, means in worst possible case the Zener diode current should be more than its minimum value, but in this question IZ minimum is not mentioned, so we can assume it to be 0. Okay, so here I have written the equation. This is the equation. Okay, this is the current across RS, this is the load current, and this is total, this minus this is your Zener diode current. Okay, it should be more than Zener diode minimum current. Here it is, nothing is mentioned, so we will assume to be 0. Now this V minimum, that is the source minimum, we know it is 8. Vz in the question it is given 5. IL max is 150 milliampere, in the question itself it is mentioned. Now RF, we have to find out this values. Now we can simply solve this equation and it comes out to be this one. R should be less than equal to 20 ohm. Okay, so the maximum possible value is 20 ohm. Okay, 20 ohm. So this is the, now we can also write the equation for another worst possible case scenario, that is when this is maximum and this is minimum, but we are not going to get we are going to get basically similar kind of value. Okay, it comes out to be r more than 0, so it is of not that much use. So we can easily get the answer from the first condition itself. Sometimes it is asked to find out the range. Okay, in that we are going to get some good value from the second equation also. Okay, now one more part of this question is, say, what is the maximum power across RS? Okay, what is the maximum power dissipated across the RS? This is very easy question. Now this should always be in breakdown. Okay, so maximum power will be dissipated when this fellow is maximum, because this is always going to be constant, that is the breakdown voltage, it's 5. Okay, so this is variable, so the maximum power dissipation across this one is going to be I square into R. I is V, that is the 12 volt maximum, minus 5 by RS just we have found out, then RS is same value. Okay, so you can calculate from that also. Okay, so it comes out to be around 1.45 watt. Okay, IA square RS. Okay, so let's meet in the next question. Thank you.